into it. So you can see we'll be talking about data sets and filtering, calculations, as well as user input. So data sets, what are they? Data sets are used to pull information in from the database. You can add criteria based on the trendable fields. This is essentially the first step in filtering the data to be more relevant to the user. We talked about those trendables last week. When you run the data set, you also give yourself the ability to see the data points plotted on a CAD or FEM model. These data sets can be saved for future use, and you can control who has access to the data set. So if it's something only critical to one functional area, you can set it up on their machines, or you can make it public for the entire enterprise. To access the existing data sets, there's a load existing data set feature. This tool is used to bring in already existing public data sets so as not to repeat the work needed to create them again.
Just a quick note on that. For those of you who have not yet transitioned to Nline 7.1, if you're an administrator, the very first time you go from 6.11 to 7.1, it'll ask you to convert everything to data sets. And so your what used to be called trending filters will become data sets. And then to access them, you'll just load the data sets like this was just talking about.
So we'll continue on here. So this is showing you that you can select the data sets from a list and you can load multiple at one time. Might be worth noting here that if you are running multiple functional areas on the same database and have a lot of public data sets, it might be beneficial to come up with some sort of standard naming convention to help keep all of these organized so everybody has a way of tracking what they actually need. So just some sort of smart naming convention. So once loaded, the datasets will appear in the datasets list on the left of the Nline home screen. While it's necessary to load the sets in for essential background functions to occur, this menu also acts as a type of favorites list, as you can quickly apply all of the datasets from here. To edit an existing dataset, you can use the pencil icon, and to add a new dataset, you would use the plus icon. To unload the dataset, use the unload icon. I want to make it clear we are not actually deleting anything when we use this tool. With this action, deleting datasets, it's done in a different area of the system by an admin. The dataset is stored in the database, and if it's public, you wouldn't want just anybody to be able to delete it for everybody else. So when you unload the dataset, it simply goes back into the load screen and cannot be run by the user who unloaded it. So datasets in the editor and creator window will look like this. The filter criteria will be listed in order of operation between the database icon and the display icon. You can see this barrel looking icon is the database and the monitor icon is the display. Everything in between are operators or filter criteria a user has added. This can be an extremely powerful tool when you're trying to focus on specific data. For example, if you wanted to narrow down findings for a specific inspection or determining the significance of a defect. To add new search criteria to the dataset, click and drag fields from the available column on the left to the dialog window on the right, or you can double click to bring the field into the equation. So you can see we have certain information or criteria available on the left, and to add them to the dataset is very intuitive. Like I said, you just need to click and drag where you want them. Fields available to add as criteria are displayed with an icon of the field type as shown below. You can see some pretty standard fields here. You have numeric, text, date, and user. The last n trendables is using that n as a variable, and it's just referring to how many trendables back you want to see. We also have signatures, lists, and the named or dynamic regions that you can specifically say you want to be looking at. So a little more in depth on the editor window here. This is showing you that you can filter the fields that show up by clicking the Show Fields For dropdown. The default is to show all the fields for all trendable types. So making a selection from this dropdown changes the list to only show fields pertaining specifically to the trendable type that you've selected. You can see on the right side of the screen, we break up the available fields into 3 types. You have common fields that every single trendable will have available. You have calculated fields that we'll talk about here in a minute, and all of the other fields are available depending on your filtering selection. Like I said, if you select a filter up at the top for a specific trendable, that all other fields selection there will be limited to only that trendable type. When adding a field you want to search by, a filter pop-up window will appear. You can see in this example, you want to filter based on flight hours. You simply choose an operation and then give it a value. So based on the selected field, the filter questions may be different. In this example, we've selected a list filter, and it brings up all the available values that you can select. You can select just one or multiple, and the previous example, again, was just a numeric field, so we only needed a number. Here you have this list. It has to already be populated with, in this example, the trendable types. So basically, each of these different fields are going to have a unique set of criteria that you'll need to give them. Once a data set is created, it can be made public or private by clicking on the little person icon next to its name. He's kind of small, but you can see him up here. And this is how you toggle between public and private. Be sure to include a good description for other users. This goes back to what I said about having a smart naming convention. Obviously, having a good description is just as important. So these are the controls from the main screen after we have already created and loaded in our data set. You can see how you'd open a window for the data set, whether it's a model, a graph, or a results table. Clicking any of those buttons will open the visualization tool that you want to use. You can quickly apply the data set to all of these open windows at once. After you do that, you just hit run to actually execute the data set, and it'll show all of your trendables. An alternative way to run the data set is to select them from the drop-down at the top of each window. Each window you have open can have different data sets displayed in it. You can also see on the left-hand side of the slide, the calculation data set hasn't been run yet, and no data has been pulled in or displayed. On the right, though, you can see the run button has been changed to an update button, as the trendables have already been pulled in from the server, and you would only need to update the given set if a change had been made. So one can also add calculations to the data sets in the same way as filtering. Just clicking and dragging an operation from the calculate window on the left to the dataset window on the right, or you can double click. So we give you guys a set of operators to perform just about any calculation you would need. This is very similar to how filtering works. You just click calculate and it gives you a menu full of operations. This slide shows the calculate button in the top left-hand corner because it's already been selected. Before you select this menu, though, the calculate button is actually in the bottom left. But from there, again, you just click and drag options onto the data set on the left. Once the calculation is added, input fields, which will be included in the operation, and the output name. Okay, so here is where you're specifying what the calculation is actually doing and what your variables are. And then you can just specify what you want the outcome to be named. Once the calculations are added, it will ask you if you want to output the calculation result. If the calculation is the output, it will be visible in the trending results window next to the trendable type it was calculated for. So this is a relatively simple concept. If the calculation is the final answer you're looking for or is otherwise significant, you'll want to check that box just to make sure it's output and visible to the engineer or anybody who's using the data set. Otherwise, it'll just be used in the background in other calculations. Once you've added a calculation to the data set, you'll notice a line that separates the search functions from the calculate functions. This just gives you a clear separation of the field types and makes keeping your calculations organized much easier. It's easy to see what each of the fields are by using the icons on the dataset's editor window. You can clearly see if a field is a number, a calculated field, or one of the results to be displayed in the trending results window. In addition to the search and calculate divider, these icons designate the action taken. These are common throughout the entire dataset editor window. You can see the filter, calculation, and output icons, and also the user input icon. And groups. Groups can be thought as a parenthesis in a calculation to change from the default operation of and double click and it will change to or. So this is pretty self-explanatory. Occasionally you need to group calculations together. This is how you would do it. Just click and drag the group operator on the left and drop the fields into it on the right. And again, if you need to change this from an and, you just double click and it will change to or. Okay, so now we're transitioning a little bit to talk about user inputs. These are fields that are dynamic and you allow the user to determine what value they specifically want to filter data on. The criteria can be changed from static to user input by toggling using the little blue man icon when you're setting up the actual parameters for the filtering field. So this comes up when you actually select one of those fields to put into a data set. Some of them allow you to toggle the user input, some of them don't. It just depends on the field that you're trying to put in. Once inputs have been set, they will appear on the left side of the dataset window. Again, this is just a measure we take to ensure that the user can keep all their calculations and filters well organized and can quickly identify what's going on just by looking at the screen. After closing the dataset editor window, the inputs will appear on the lower portion of the data tab, as you can see down at the bottom here. So this allows the users to dynamically change the inputs. Once all of the inputs are set, you can quickly apply the changes just by using the Apply Changes button here. So now we have an example problem. In this example, we'll be creating a data set to show us all the trendables for the corrosion type, setting up a calculation for the corroded area, and creating a user input field to allow users to specify the size of the corrosion that they want to see. So first, we're going to open up Nline. First thing you'll notice, we have the dataset menu over here on the left-hand side of the screen. The first thing I mentioned we're going to do is actually create a dataset. So we're going to use the plus icon up here at the top. And it pops open our new dataset window. We're just going to name this something fairly generic. We'll call it Intro Class Week 3. And now the instructions are to just add a data set to see all of our corrosion trendables. So from the left-hand side over here, we're just going to click this trendable type and drag it over. And when we drop it, it brings up this new selected items filter. So we're only looking for corrosion trendable types. So we'll click that. If we wanted to see cracks or dents, we could also click those and add them in. But again, in this example, we're just looking for corrosion. So I'll hit select. It adds it in. We can run it from here. We can see that we get 34 results. If I save this and close it, if we go up to the top, like this, since we ran it in the last screen, now you can already see these points are plotted and showing up on our model. Now to give you a better view, I'm actually going to open this into a trending results screen. I can do that very quickly just by clicking on the data set here on the left-hand side and opening the results table. All right. It even highlights the trendable that I clicked on the model over here. So next, we're going to edit this and add in a calculation to calculate the area of these corroded areas. So we're going to use the pencil icon up here at the top. And we want to create a calculation. So we'll click this calculate button down here at the bottom. And it brings up our menu. We have all these different operators to choose from. Since this is just area, it's very simple. Just double click multiply. Again, I could also just click and drag this over to the dataset area, but double clicking also works. So we want to multiply the value of our length by the value of our width. And we're going to output this to a field called area. And I want to output the result because I want to see this in our trending results table. I'll hit OK. You can see it brings it up over here. We can run this again. You see we get 34 results, same thing. I'll hit save. We'll close this. And we'll update. This just updated all of our values here. And if we scroll over, we can see this area has been calculated. Now, it has not been calculated for these other trendables down here because they were brought in without a length and width. See here, these are all blank. Same with the width. But this one up top, we have an area of 13.2. So now the last step in this example problem, we want to edit this again so that we can add in a user input that they can actually define how big of a corroded area they want to look at. So, if it was under 2 inches, they might not want to see it. If it was over, 5, they would want to see it. We're just going to add in a quick one. So we'll go back to the editor screen. And you can see after we input our calculation over here, we get this new field over here on the left-hand side of the screen for area. If we just double click that, it brings up our filter window. All right. Now here's where we can actually specify a hard number in here. Let's say we didn't want anybody using this filter to see anything less than 2, right? So 2 square inches of corrosion. We would hard set that number and they wouldn't be able to change this. But since we do want to add in this user input field, all we do is toggle this blue man over here, click him, and it grays out this field here. We'll click the drop down and hit new user input, and it'll ask us for a field name, and we can also specify a default value. So this field name we're just going to call user input area. And we'll put the default value as 5. So right now, it'll only show us any area greater than 5 square inches. We'll hit OK. We'll hit select. And now you can see this new field populates over here on the left-hand side of the data set. And it specifies our user input. Again, we're going to hit run. And you'll see here, this dropped from 34 to 1 result, because 33 of those results did not have an area specified because they had their length and width empty. We'll click save here and close. And you can see this has already been updated here at the top. We only have that one trendable. If we come over here, put in 0. Still not bringing anything in just because they were empty fields. We're now giving it a specific area to include in our trending results table. Okay. So that should be it for the example problem. We went ahead and created a new data set. We did a calculation within that data set and added a user input. Any questions before we continue on here about that example problem that we just did?
Yeah, so I saw that your list of calculations included a number of operations. Is it possible to add to that list and add your own custom calculation?
So there are many mathematical operations that you can tie together. There's also, you can use and or statements. You can group things in the calculations. So you can have fairly complex calculations, but the mathematical operations.
I got you. So you can just string them together, basically, if you need to use multiple ones back to back.
Okay. So here's an example of one that has multiple operations. There's just kind of 3 major things that help divide and help you keep track of the data. On the far left column are all of the user inputs. In the center column are all of the filters. And on the right column are all of the calculations or operations in this data set. So that helps you kind of organize. If you see the little lines coming off of that center line, those are the names of the variables that are output from the operators on the right. Very first calculation there is input into a variable called year diff or year differential. It calculates, some subtraction between 2 years in this one. So and then it goes on to calculate various other operations as well, and then has an output and things like that. So yeah, you can string multiple operations together. So we've got different binary operators, your basic algebra, add, divide, log, multiply, subtract. So we've also got absolute value, different trig, square root, and then aggregate, counts, max, mean, median, standard deviation, things like that. So it's a very powerful interface as far as being able to set up an output.
Yeah, I see. I didn't think I grasped the fact that how you string them together. Now I get it though.
Yeah, so it's almost like you can create your own application or your own, not exactly code, but string of operations to calculate and output different variables. You can even store some of these variables onto individual records. So I think one of the simple examples we like to do is creating like a defect area. Let's say a technician records a length and width. You can easily calculate an area from that via a multiplication operator and then store that area calculation back into one of the records. So you could do other things with like crack length growth over time and things like that as well. You could do all kinds of different stuff that you record, calculate.
Awesome. Thank you.
Yeah, sure.